This video is about physics, and in this video I will be dealing with the topic law of conservation of momentum, which tells us how momentum gets conserved before and after interaction between two objects, provided that there is no external force acting at the time of interaction. Let us learn how does this law occur in nature. We all know that momentum equals mass times velocity. According to the law of conservation of momentum, this mass times velocity or momentum gets conserved before and after interaction between different objects, provided that there is no external force acting on the time of interaction. Now, let us take a look at an example of this law at work. Here, a rocket is getting launched. We are seeing here that as the rocket burns more and more fuel, it gains more and more velocity. And we would obviously infer that the momentum of the rocket gets conserved in this case. But that is not so, because here the gravity of Earth is trying to pull down the rocket, which reduces the velocity had there been no gravitational force acting on the rocket. But in space where there is no gravity, this example would be perfectly right. Let us take a look at another example of this law at work. Here a gun is being fired. Initially, both the gun and the bullet were at rest, but after firing, bullet with a smaller mass moves with a greater velocity, and the gun, which is having a larger mass, moves with a smaller velocity. And so here we can conclude that momentum is being conserved, provided that there is no external force acting on the time of interaction. We can also observe this law at work in many more examples around us. Let us look into the theory behind this phenomenon. Newton's third law states that every action has an equal and opposite reaction, and the action and reaction forces will act on two different bodies. We are having two bodies A and B, in which A is initially at motion and B is initially at rest. Now A is at rest and B is at motion. From here we can say that force exerted on A by B equals to the force exerted on B by A, provided that there is no external force acting on those objects. Let us learn how to derive the expression of this law in nature. From the previous theory, we can now conclude that force of A exerted on B equals to the force of B exerted on A, which means mass of A times acceleration of A equals to mass of B times acceleration of B in the negative direction to A. We know that acceleration equals to final velocity minus initial velocity whole divided by the time taken for the object to accelerate. And here goes the simplification. And finally we are getting momentum of two objects before collision equals to the momentum of two objects after collision or interaction, to say properly. Conclusion. Now, what do we conclude from the previous things we have learned? We have concluded that momentum of two objects before collision equals to the momentum of two objects after collision. This is only the law of conservation of momentum. This law is very useful and it has many applications, like in Newton's cradle experiment, shooting of a gun, launching of a rocket, etc. Thanks for watching this video.